You close your eyes, and the world around you softens into silence. The busy rhythm of the day loosens its grip, and you find yourself drifting into the wide expanse of night. Above you, the stars begin to appear, one by one, as if they're being gently lit by a careful hand. They shimmer in the distance, each a glowing point of fire, resting on the dark velvet of the sky. You float there in your imagination, far above the noise of life, where time feels slower and gentler. In this space, you begin to notice not only the stars themselves, but something quieter, a sense that they are not separate, not truly isolated sparks. Instead, they seem to belong to something larger, as though invisible threads tie them together across the night. The stars twinkle, and you feel them whisper. Nothing drifts alone. This idea feels familiar, even comforting. You know in your own life, in the way you are connected to others, even when you are apart, a voice remembered, a thought of someone you love, the way their presence can linger even across distance. These human feelings echo, in some small way, the mysteries of the universe. And so, you let yourself imagine, what if reality itself is stitched together by threads too fine to see? Threads that stretch not just between people, but between particles, the smallest pieces of everything. Here begins a story of entanglement. You picture two tiny particles, smaller than dust, smaller than anything your eyes could ever see. They are born close together, perhaps from the same burst of energy, the same spark of creation. In their birth, they form a kind of bond, not like glue, not like a rope, but something deeper, stranger, a connection written into their very being. Now imagine these two particles drifting apart. One moves left, the other right. Time passes, distances grow. They travel farther and farther until they are separated by a stretch of space, so vast it feels impossible that they were ever close. And yet, they remain tied together. What happens to one is reflected in the other, instantly, with no delay. You sit with that thought, letting it unfold slowly. A connection that distance cannot weaken. It feels almost like magic, but it is not. It is nature, revealed in one of its most mysterious forms. Scientists call it quantum entanglement. To ease into its meaning, you might imagine again those stars above you. At first glance, each star shines on its own. But if you allow yourself to dream, you might see thin silver threads stretching between them, like a cosmic web. The light of one is tied to the other, and the night sky is not a scatter of points, but a woven tapestry. This picture is only an image, a metaphor. The real entanglement happens not in stars, but in the quantum world, the world of the unimaginably small, where particles dance in ways that seem to defy common sense. In this world, particles are not simply here or there. They exist in a haze of possibilities, as if they are shimmering clouds of maybes. When two particles become entangled, their maybes intertwine. The outcome of one is no longer its own. It belongs to both. You pause in this thought, like resting by a gentle stream. The sound of the water is not urgent, not demanding. It simply flows. And so does this idea. Entanglement is a flow of connection, not bound by space. Some people describe it as a kind of invisible communication, but that word can feel misleading. It is not that one particle sends a message to the other. It is that they share a single story. Like two dancers moving in unison, they are not separate performances. They are one dance, even if they stand miles apart. The night deepens, and you picture yourself floating further, drifting past Earth, where the blue oceans and green lands grow small below you. Stars surround you now in every direction. In this vastness, the thought of being connected feels even more soothing. You reflect on the times you have felt alone, perhaps sitting quietly in your own room, wondering if your life is just a small flicker in an endless universe. Entanglement reminds you of another possibility, that even in emptiness, threads exist. They tie you not just to other people, but to the very fabric of reality. Scientists who study this do not describe it as poetry. They measure it, test it, challenge it with questions. They place particles far apart and observe their behavior. Again and again, the result surprises them. The bond holds, the connection is real. It is not imagination. It is truth. And yet, as real as it is, entanglement resists simple explanation. Einstein himself struggled with it, calling it spooky action at a distance. He could not accept that nature allowed such a thing, that particles could be linked across space without something traveling between them. But experiments have shown, time after time, that this strangeness is part of how the universe works. You let that thought rest gently in your mind. Even the greatest thinkers wrestle with mystery. And perhaps that is part of the beauty. That reality is not always neat, not always fully understood, but alive with wonder. Now, as you float among stars in your imagination, you begin to sense a deeper truth. The threads that tie the universe are not just cold mechanics. They can be felt like a presence, like a whisper reminding you that separation is never absolute. You breathe slowly, and with each breath, the stars seem closer. The invisible web feels softer, as though it cradles you. Entanglement may be a concept of physics, but here it becomes a comfort, a way of knowing that nothing exists in complete isolation, not even the smallest particle, not even you. Your mind drifts further into the metaphor. If particles can remain connected across light years, perhaps the connections you hold in your life, to family, to friends, to those you've loved, also stretch farther than you imagine. They, too, may be part of an invisible fabric, subtle but unbreakable. And so, as you rest in this thought, you begin to wonder, what happens when two particles choose each other? What does it mean for them to be bonded so deeply, to share outcomes across space and time? The stars above shimmer as if waiting, and you drift toward the next question, carried by threads that are always there, always holding, always whispering that nothing drift alone. You imagine yourself standing at the edge of a quiet meadow at dusk. The air is cool, the sky painted in gentle shades of fading light. Around you, the world feels still, as if it is holding its breath. In this calm, you sense how bonds are formed, how connections take root in silence, how they stretch beyond the moment. Think of two friends. They walk together, share laughter, share secrets. Over time, they drift apart, one moving to a distant place, the other staying behind. The miles grow long between them, yet something remains. When one feels joy, the other seems to know. When one suffers, a shadow crosses the other's heart. It is a connection not of wires or letters, but a memory of closeness that never breaks. Particles, in their own quiet way, carry a bond like this. In the smallest world, the quantum world, two particles can become paired. They are born together, like twins in the same cradle of energy. This birth leaves a mark upon them, a connection that does not fade with distance. To say they choose each other is a metaphor, of course, but it feels true. For once they are entangled, their paths are forever linked. You picture them as sparks, dancing in a dark sea. At first they are side by side, spinning together, their movements a mirror of one another. Then, slowly they drift apart. One spark moves left, the other right. They continue on their separate journeys, perhaps even across galaxies. And still, when one spark turns, the other turns too, instantly, as if the space between them is an illusion. It is not a message being sent, not a signal racing through the void. It is more subtle, more intimate. They are not two separate stories, but one. The universe has written them into a single sentence. You breathe slowly, letting this image settle in you. Two particles, forever echoing one another. To understand this, you might return to the image of the meadow. Imagine two leaves on a single branch. A breeze comes and both leaves sway. If you were to pluck them and carry them to opposite sides of the field, you might expect them to dance differently in the wind. Yet in entanglement, they do not. Though the branch is gone, though distance stretches between them, they continue to move as though tied by an invisible thread. This is what astonishes scientists, that such a bond, formed in closeness, does not weaken with space. If you place one particle here on Earth and carried its partner to the farthest edge of the galaxy, their link would still hold. The instant one is measured, the other's state is known. You linger on that thought, instant, as if the very idea of distance does not apply. It feels like a secret of the universe, a quiet reminder that space may not be as empty as it seems, that underneath the fabric of reality, there are patterns of togetherness, threads that cannot be broken. And you might ask yourself, why does nature do this? Why would particles hold one another in such a deep connection? The answer, for now, is not fully known. The mathematics of quantum physics describe the bond, but it does not explain the why. And perhaps that is part of its beauty, the way mystery hums beneath knowledge, the way wonder is always left alive. You step further into the meadow of your imagination. The air now filled with soft stars rising in the evening sky. They shine above you, pairs and clusters scattered across the darkening blue. Some are binary stars, true companions bound by gravity, circling each other endlessly. Others only appear close, though separated by light years. Yet, in entanglement, closeness is not required. Bond does not depend on distance. It is as though nature says, once touched, forever tied. You recall again the idea of friendship, a bond you have felt in your own life, the way a connection with someone can remain even when time and distance intervene. How a memory of shared laughter can live quietly inside you, reshaping the present. In this way, entanglement is not so foreign. It is both strange and familiar, both science and metaphor. When scientists first discovered this, it unsettled them. Einstein cannot accept it. He believed the universe must be local, that what happens here cannot affect what happens there without something traveling between. Yet experiments kept showing otherwise. Time and again, the particles seemed to agree instantly, no matter how far apart. It was as if nature itself cared little for the boundaries of space. You rest with this idea gently, not needing to force it into certainty. Science here is less about final answers, more about walking through wonder. In the quiet of the meadow, you imagine two fireflies lifting into the night air. They glow in rhythm, one flashing and the other answering, though they drift apart on different breezes. To an observer, they are far, yet their light feels shared. Their glow, like the entangled particles, is not two separate stories, but one unfolding harmony. Entanglement is not a choice in the human sense. It is not love or memory, not will or desire. And yet, to you, it feels like closeness, like kinship, like the echo of one heart within another. Science names it, measures it, studies it. But you, lying beneath the stars, feel as poetry. This is a heart of entanglement, a bond not weakened by distance, a union written in the very laws of nature. You close your eyes, holding the image of those two particles, once close, now drifting far apart, yet still whispering the same story. Their togetherness is invisible, but real. Their connection is silent, but unbreakable. And as you rest with that, a new question begins to rise. How do these particles, so small, so hidden from your eyes, carry such mystery in their existence? How do they live in states of possibility, as though they have not yet chosen, as though reality itself waits to decide? The thought lingers, gentle and unresolved, carrying you toward the next chapter, where probability becomes poetry, and a coin can land on both sides. You sit quietly, and in your hand, you imagine a coin. Its edges gleam softly, catching the light of a fading day. You feel its cool weight, the simple circle of metal that has served humanity for centuries as a way of choosing. Heads or tails, this or that, yes or no, a decision made by the flip of chance. Now, you toss it gently into the air. The coin rises, glimmering, and begins to spin. In that brief suspension, as it turns, it is not yet one thing or the other. It is not heads, not tails. It is both, living in the hazy freedom of possibility. Only when it falls into your palm does the choice reveal itself. This moment, that pause in which the coin is still undecided, is where quantum particles spend their lives. You close your eyes and picture not a coin, but a particle, one of the smallest building blocks of the universe. Unlike the familiar objects of your world, it does not exist in a single, certain state. Instead, it hovers in superposition, a word that means it lives in many possibilities at once. It is as though nature itself allows the coin to keep spinning, never force a land until the moment you look. You breathe slowly, letting this image settle in your mind. A universe where certainty waits for observation, where reality itself seems a pause in mystery. Think of a room with the curtains drawn, the light dim, and a bird perched on the windowsill. You do not know if the bird will stay or fly away. In your mind, it is both present and gone. The truth is undecided until you look. That is how particles live. In the softness of uncertainty, in the poetry of maybe. Now return to the coin in your hand. Imagine flipping not one, but two coins bound together in a mysterious way. They spin through the air, shining arcs of possibility. Each is free, each undecided. And yet, when one lands, the other answers. Heads here, heads there, tails here, tails there. Always in agreement, no matter the distance. This is entanglement woven into probability. The moment of decision for one is the moment of decision for both. You linger in this image, letting it expand. The world of the very small, the quantum world, does not obey the neat rules you are used to. In your daily life, objects are solid, predictable. A chair is a chair. A stone is a stone. But in the quantum world, objects shimmer in possibility. They are waves of potential, rippling through space. Only when observed, only when measured, do they collapse into one outcome. It feels strange, perhaps even unsettling, to think of reality as undecided. And yet, there's something deeply calming in it too. The universe is not rigid. It is not locked. It breathes with openness, with choice. You think again of the coin spinning above your palm. The longer it turns, the more beautiful its uncertainty becomes. It is not rushing to conclusion. It is savoring possibility. This is the gift of the quantum world. To remind you that uncertainty is not some to fear, but something to embrace. Just as in life, when the future is unclear, you are not yet trapped. You are still in the air, still free to turn, still both heads and tails at once. You picture two coins now, far apart, perhaps one in your hand and the other across the sea. Both spin, invisible to each other, yet bound in secret agreement. When one lands, the other mirrors it instantly. No signal sent, no messenger running between, just a shared destiny, written in probability. Scientists describe this with mathematics, careful equations that trace the curves of possibility. But to you, lying beneath the stars of imagination, it feels like poetry. The poetry of chance becoming harmony. The idea unsettled even the great minds. Einstein struggled with it. He wondered how a coin here could know about a coin there, faster than any light could travel. He suspected that something was hidden, some deeper mechanism not yet discovered. But as experiments grew more precise, the evidence grew stronger. The coins really do agree instantly across space. You pause to let that truth wash over you. The universe, at its heart, is not a rigid machine. It is a dance of probabilities, a song of maybes, bound by threads we cannot see. You picture again the coin in your hand, spinning, suspended. It becomes a symbol of all the choices in your life not yet made, all the futures not yet chosen. You live, in some way, like the particle, in possibility, in superposition. Perhaps you have felt this before, standing at a crossroad, unsure of which path to take. For a moment, both paths are real. Both futures breathe inside you. Only when you step forward does one become your story. Particles live this way always, until measured. They're the embodiment of openness. And yet, once measured, once observed, they resolve. The coin lands. The outcome is chosen. The haze clears into a single reality. This collapse, from possibility into certainty, is how the quantum world shapes the world you see. You rest in this thought, that beneath every solid object, every stone, every tree, every star, there's a hidden life of uncertainty, constantly spinning like coins in the air, constantly waiting to land. And when two particles are entangled, their spinning is not separate but shared. One coin cannot land without the other deciding too. Their probabilities are braided together, like strands of hair woven into one. You imagine holding two coins now, tossing them into the air at the same moment. They rise, gleam, and spin. And though you do not yet know how they will land, you know they will agree. Always together, always echoing each other's truth. It is strange, almost unsettling, but also beautiful. A reminder that even chance itself can carry harmony. The night grows deeper in your mind. Stars thickening above you, shining like countless coins frozen mid-flip. Each star, each particle, a shimmer of possibility, each outcome waiting to unfold. You let yourself breathe with this rhythm. Possibility, uncertainty, harmony. The words repeat like a lullaby. Possibility, uncertainty, harmony. The spinning coin grows softer in your imagination, their edges blurring, their shimmer fading into waves of light. You drift with them, into the haze of probability, into the comfort of knowing that reality itself carries openness in its heart. And then, gently, a new thought rises. If particles can live in such state of uncertainty, if they can flip like coins suspended between outcomes, what does it mean when great minds, like Einstein, stop to question them? What does it mean to call it spooky, to wrestle with mystery even when the evidence shines clear? You rest with that question, gentle and unresolved, drifting toward the next chapter, where Einstein's puzzle heart waits for you. You close your eyes and let the image of Einstein drift into your mind. His hair, untamed like a halo of questions. His eyes, soft yet sharp, carrying both kindness and a restless hunger for truth. He is not just a figure of equations and chalkboards, but a human heart, curious and cautious, moving slowly along the path of mystery. For Einstein, the world was a place of order. He believed in laws as steady as a river's flow, rules that guided stars and stones alike. He trusted in the beauty of clarity. To him, physics was not just a science, but a kind of music, an elegant symphony played by the universe itself. And yet, here was something that disturbed him, something that felt less like music and more like a strange whisper, a note that did not belong. It was entanglement, the thought that two particles, once connected, could remain linked even when torn apart by distance, a bond that ignored space, a tie that no instrument could measure yet. Einstein called it spooky action at a distance. The phrase itself feels almost playful, as though he tried to soften his unease with humor. But beneath the smile, there was real discomfort. For him, nature should be grounded, predictable, bound by the limits of light and time. But entanglement seemed to break those boundaries, moving faster than light, mocking the very structure of reality he cherished. Imagine Einstein sitting at his desk, fingers tapping lightly against the wood. He looks at the equations again, those delicate strokes of logic. The math seems to suggest that two particles, once joined, could act as if they were still one. If one leaned left, the other leaned right, no matter the distance, as if the universe carried an invisible thread between them. But Einstein resisted this picture. He did not like the idea of invisible threads. To him, physics was about things that could be seen, tested, touched by the light of reason. Entanglement felt too much like magic, too much like the world giving an answer without showing its work. He wrestled with it gently, like someone wrestling with a dream upon waking. He did not deny the strangeness, but he questioned whether the strangeness was real. Perhaps, he thought, we simply do not see the whole picture yet. Perhaps the particles share hidden instructions, secret notes written before they part ways. When one is measured, it is not the distance that matters, but the plan they carried from the beginning. This belief became his shield. Hidden variables, he called them, private agreements between particles, unseen to us but faithful to them. To Einstein, this explanation preserved order. It kept the universe honest. It kept nature grounded. And yet, his heart remained puzzled, for he knew, deep down, that if no such hidden notes existed, then reality itself was stranger than he ever wished to admit. Pause here with him. Sit in that room of thought, where chalk dust floats like quiet snow, and a man known for clarity sits in gentle confusion. Notice how human this is. The feeling of reaching for certainty and finding only mist. Notice how even great thinkers are not immune to wonder's weight. What is striking is not that Einstein resisted, but that he resisted with love. He did not want the universe to be less beautiful. He wanted it to be more complete, more elegant, more truthful. His doubt was not the doubt of rejection, but the doubt of someone unwilling to settle for shadows. And so, while others celebrated entanglement as a doorway to mystery, Einstein called it spooky, not because he wanted to close the door, but because he felt the chill of stepping into a room without light. You can feel this tension inside yourself too. The longing for clarity, the desire for answers that rest firmly in your hand. And yet, the world often gives you riddles, delicate puzzles that cannot be solved in a single glance. You want nature to whisper softly, "Here's the truth." But instead, it often sings in riddles, melodies that circle back upon themselves. Einstein's puzzle heart reminds you that it is okay not to understand. It is okay to pause, to breathe inside the mystery. Doubt is not failure. It is the place where curiosity begins again. Think of the phrase once more. Spooky action at a distance. A phrase both playful and haunted. Spooky because it unsettles. Action because it moves. At a distance because it defies space. Each word carrying weight, together forming a thought that still shivers through physics today. Over time, experiments leaned toward the spooky rather than the hidden. Bells were tested, inequalities challenged, and the universe revealed, piece by piece, that entanglement was no illusion. It was not a trick. It was real. The threads were there, not written in secret notes, but woven into the very fabric of existence. And perhaps, if Einstein were here now, he would not frown forever. Perhaps he would let his puzzle heart soften into wonder. Perhaps he would smile again, realizing that even the strangest truths can still be beautiful. For now, you carry both sides of his heart, the love of clarity and the willingness to sit in mystery. You feel the rhythm of his thought like a soft heartbeat beneath your own. You walk with him in that quiet room, knowing that questions need not be answered all at once. Entanglement does not erase Einstein's wisdom. It simply shows that the universe holds more than one kind of beauty, the beauty of rules, and the beauty of mysteries that rules cannot yet contain. Rest here with this thought. The greatest minds are not those who know all, but those who stay open to the unknown. The universe is not diminished by mystery. It is deepened by it. And so are you. Stay here, breathing with the mystery, letting it settle like twilight upon your mind. Feel the way doubt turns not into despair, but into a softer kind of faith, a faith that the story of reality is larger than you can yet see. And as you drift with this thought, let your mind begin to open toward what comes next. For if Einstein's puzzle heart trembled at the idea of spooky action, what happens when the world begins to test it? What happens when experiments take mystery from dream into proof? The answer waits, just beyond this page, like a candle flickering in the next room. Close your eyes and imagine silence. Not the silence of a quiet room, nor the pause between heartbeats, but a deeper silence, the kind that seems woven into the fabric of space itself. A silence so vast, so endless, that even light takes years to cross it. Now, in this silence, imagine a whisper, not a loud call, not a shout carried on wind, but the softest exchange, one that does not need sound at all. This is how entanglement feels. A cosmic whisper, a hidden nod exchanged between two particles that once touched. When one changes, the other responds, instantly, as though they are still together, as though distance itself has no meaning. You sit with this thought gently, almost afraid to disturb it. It is delicate, like a spider's web catching the morning dew. If you lean too close, it trembles. If you tug too hard, it breaks. Entanglement is like that, a fragile, almost ghostly bond, a communication that is not really communication at all, but something stranger, deeper. You know how sound travels. A word from your lips moves through the air, riding waves of vibration until it reaches another ear. You know how light travels, faster than sound, racing across the dark. But this is something else entirely. A change here, and there is no delay, no travel, no waiting. It simply is. Two particles, one gesture, one silent reply. It does not matter if the particles are near or far. You could place one on Earth and send the other to a star 1,000 light years away. Still, if you touched one, the other would feel it immediately. No messenger runs between them. No signal races ahead. They do not speak across distance. They remain as though distance never separated them. Think of two dancers who once moved together. They spin apart, drifting to opposite corners of a vast stage. Yet when one raises an arm, the other does the same, perfectly synchronized. You might think they rehearsed or that they carry hidden instructions. But in quantum entanglement, there is no script. Their movements are linked in real time, written not in advance, but in the very moment of choice. That is why it feels like a whisper, not a message that travels, but a truth that simply appears. For you, it is almost impossible to imagine silence without distance. So much of your life is built on separation, here and there, before and after, cause and effect. Yet entanglement seems to fold these things together, weaving two places into one invisible thread. The universe does not ask your permission to be strange. It simply is. Scientists once wondered, if this is a whisper, what language does it use? Is there a hidden code, a signal beneath signals? But experiments showed otherwise. The whisper is not carried across space. It is not a transmission at all. It is more like a mirror, where one side reflects the other instantly. No voice, no journey, only connection. You pause here, because the idea is so tender, so strange. It almost feels like poetry. The cosmos, in all its immensity, chooses to tie together two particles with a bond invisible to everything else. And you are left to wonder, if the smallest things can stay linked across space, what else in this universe might be tied in ways you cannot yet see? In your own life, there are whispers too. A thought of someone you love, arriving before a message does. A memory that rises unbidden, as though carried on an unseen thread. Of course, these are not quantum in the strict sense, but they echo the same feeling. A reminder that distance does not always mean separation. Sometimes connection hums beneath the silence, waiting to be felt. Entanglement does not shout its truth. It will not announce itself like thunder. It lingers like a secret in the still air, revealing itself only when you look closely. That is why it has puzzled minds for so long. It hides in plain sight, its whisper woven into the laws of nature. You can almost imagine the universe as a great loom, weaving its fabric. Stars and galaxies stretch across the threads, but beneath them, entangled particles hum quietly, like knots tying distant corners together. They do not ask to be noticed. They simply hold the fabric in place. Think of it this way. If the universe were a grand story, entanglement would be the hidden rhyme, the echo between two lines far apart in the poem. It is a subtle music that connects the beginning with the end. You might not hear it first, but once you do, it changes the way you read everything. As you rest with this idea, your breath slows. You begin to sense why physicists call it mysterious. It is not just about particles. It is about the very nature of reality. If a whisper can travel without moving, if a response can come without delay, what does that say about the world you live in? What does that say about time, about space, about separation itself? The whisper leaves you with more questions than answers, but that is not a failure. It is a gift, for the universe, in its quiet way, seems to be reminding you that not all secrets are meant to be solved at once. Some are meant to be lived with, carried like a gentle tune at the edge of your hearing. You rest in that tune now, listening without trying to grasp. You let the whisper wash over you like a soft tide. You do not need to understand fully. It is enough to know that the whisper is there, binding distant places with invisible care. And just as you begin to settle into the silence, another thought arises. If entanglement is a whisper, quiet and unseen, how can we be sure it is real? How do you prove a ghostly connection, one that cannot be shouted, only felt? The answer lies not in silence, but in the experiments that dare to listen. You rest in the thought of whispers, how two particles speak without sound. Yet a question lingers, tender but insistent. Is it real or is it illusion? The mind does not settle easily with mysteries. It longs for proof, for signs that can be measured, written down, and shared. And so, you find yourself walking into the patient world of experiments, where scientists move like careful gardeners, tending to fragile possibilities. Their tools are not shovels or seeds, but detectors and beams of light. Their soil is the emptiness between particles. Their harvest is truth. Imagine a quiet laboratory, not noisy with clanging machines, but hushed the way libraries hum with soft reverence. In this space, physicists gather not to break the silence, but to listen to it. They are listening for the hidden rhythm of entanglement. For a long time, skeptics believed that entanglement might be nothing more than a clever trick of statistics, a mirage in the desert of numbers. Perhaps they thought particles were not whispering at all. Perhaps each carried secret instructions from the very start, like two coins marked in advance to land the same way. The universe, they imagined, was simply hiding its cards, giving the illusion of connection when in fact everything had been determined beforehand. This doubt was natural. The human mind prefers a familiar, causes with effects, distance with delay, reasons you can follow step by step. But entanglement refused to play by those rules. And so the challenge was born. Could anyone design a test to reveal whether this bond was genuine or merely a shadow of hidden arrangements? The answer came from a quiet thinker named John Bell. In the 1960s, Bell proposed an idea that would change the way we listen to the universe. His thought was simple in essence, though wrapped in equations. If particles were only following hidden instructions, then their responses would fall into certain limits, like footprints repeating on a narrow path. But if entanglement were real, if the whisper truly crossed space without signal, then the pattern of responses would stretch beyond those limits. Think of it like a pair of dancers again. If they practice a routine in secret, their movements, when separated, would follow that script. Predictable, confined, rehearsed. But if their movements were entangled in the present moment, the steps would break free of the rehearsal, weaving together in a way no hidden script could explain. Bell gave scientists the tools to tell the difference between a memorized dance and a living connection. And so the experiments began. Picture a beam of light split into two, like a river dividing into twin streams. Each photon, a particle of light, carries with it a spin, an orientation as delicate as the tilt of a leaf in the wind. When entangled, these photons share a bond so deep that when one tilts, the other tilts too, no matter how far apart they travel. Scientists built detectors, placed miles apart, to measure these spins. Each measurement was like flipping a coin, asking the particle, which way will you turn? Alone, each result seemed random, but when compared, patterns emerged, patterns that whispered a connection. Time and again, the results spilled beyond the limits of hidden instructions. The dancers were not rehearsing. They were moving in real time, tied by something deeper than distance. Bell's inequalities, as they were called, were broken. The universe had chosen to reveal its secret. Entanglement was not illusion. It was real. You let this sink in slowly, like a stone settling to the bottom of a clear pond. Entanglement was no longer just philosophy or speculation. It had been seen, measured, confirmed. The invisible bond had stepped into the light. Yet the story does not end here. For each experiment raised new questions. Could there be loopholes? Tiny cracks in the design that might let skepticism slip back in? Perhaps the detectors were too slow, or the choices of measurement not truly free. Scientists pressed closer, sealing the cracks, testing again and again with greater care. In recent years, experiments have grown bold. Lasers and satellites stretch entanglement across vast distances. In China, a satellite named Mishi has beamed entangled photons across hundreds of kilometers, proving that the bond holds even when particles are separated by the emptiness of space. In laboratories, entanglement has been tested with atoms, ions, even small groups of particles, always showing the same quiet truth. And still, you sit with the wonder. The bond is real, yet it remains so strange. It does not carry messages faster than light, for that would break other laws of nature. Instead, it shows that reality itself is woven differently than you once believed. Locality, the idea that objects here cannot affect objects instantly there, no longer holds in the same way. The universe whispers across distance, not with signals, but with unity. You begin to see science not as a stern judge, but as a gentle listener. Each experiment is a question asked with patience, and nature replies not in words but in patterns. The patterns, once laid out, tell a story. Particles remain connected, no matter how far they drift. Think of yourself in this story. You too are made of particles, every cell a constellation of atoms. The bond may not tie your daily choices, but it reminds you that connection is a fabric of existence. Nothing is entirely alone. Even in silence, there is a thread. The experiments echo like a mantra, real, real, real. And yet, with each confirmation, mystery deepens. For if the bond is invisible and instantaneous, what does it mean for time? What does it mean for causality? The neat order before and after. You sit with these questions the way you sit with night, knowing that not all darkness needs to be pierced, that sometimes it is enough to rest beneath the stars and feel their quiet light. The story of entanglement is not finished. Scientists continue to test, to push boundaries, to dream of quantum computers and secure communication that use this invisible bond. What began as a fragile suspicion is now the foundation of technologies being built in your lifetime. The whisper is not just poetry. It is also power waiting to be shaped. But beneath all progress, one truth remains. The experiments are not just about machines, but about reality itself. They ask the deepest of questions. What does it mean for two things to be separate? What does it mean for the universe to be whole? You breathe softly as a thought settles in you. Proof has been gathered, equations written, data collected. Yet the essence of it remains like a dream, simple, haunting, unresolved. The bond is real, but what does it tell you about the world? About yourself? About the hidden structure of everything you see? You are left with a sense that science, for all its precision, also walks hand in hand with wonder. It shines a light, but the shadows that remain are not failures. They are invitations. And as you drift deeper into this thought, another curiosity rises like a quiet tide. If entanglement is so deeply real, what does it mean beyond the laboratory? What might it suggest about the connections that thread through your own life? The invisible ties of mind, of love, of awareness itself. You hold something small in your hand. Perhaps it is a phone, glowing gently, a portal to voices and images that travel through invisible waves. You turn it over, feeling its weight. It is ordinary, familiar, yet within it, and within countless other devices scattered across your world, lies a faint heartbeat of something extraordinary, a phenomenon once thought to belong only to distant stars and hidden laboratories. This is a quiet arrival of quantum entanglement into your daily life. Once, entanglement seemed like a secret whispered only in physics classrooms, or in the careful notes of scientists who dared to test reality itself. It belonged to the invisible, a mystery hidden behind chalkboard equations and impossible thought experiments. But slowly, over decades, it has slipped from theory into practice, from dream into touch. You imagine holding two dice. You shake them, let them roll across the table. One shows 3, the other 5. They are separate, their numbers unconnected, their stories independent. But what if every time you rolled, the dice always echoed each other, no matter how far apart they were? If one landed on 6, the other answered with 6, instantly, without hesitation. Not because of hidden strings, not because of trickery, but because they were somehow sharing one story. That, in its essence, is what entanglement has given us, a shared story between particles, no matter how far they drift. And now, that story is not only a dream of physicists. It is being written into machines, into codes, into networks. You close your eyes and imagine a photon, a tiny packet of light. It is born entangled with another, like twins leaving the same cradle. Send one away, across a fiber optic cable, through the glass threads that snake beneath oceans, or even beam through open air. Keep the other in your hand, no matter the distance. When you look closely, you find their dance still aligned, their hidden coin flips still echoing one another. Scientists have used this strange connection to build the foundations of what some call the quantum internet, a network not of signals traveling slowly, but of correlations written instantly between far-flung particles. Already, Experiments stretch across cities. In China, photons have been entangled and shared between stations hundreds of kilometers apart, leaping between ground and orbit, from mountain observatories to satellites circling above. You might think, this is distant, unreachable, too large for your hand. But slowly, the gap between cosmic experiment and everyday life narrows. Inside laboratories, entanglement is being harnessed in ways that may change the very structure of computing. Classical computers, the ones you know, are like workers who can only do one task at a time, fast and sequential, carrying instructions step by step. A quantum computer, by contrast, is like an orchestra where entangled particles play many notes at once. Their harmonies interwoven, their outcomes spread across countless possibilities. When you run your finger across a phone screen, you touch glass, metal, silicon. But in the laboratories of the world, engineers are learning to entangle tiny qubits, the building blocks of quantum machines, so they can perform calculations beyond the reach of even the fastest supercomputers. Problems in chemistry, medicine, or climate modeling that would take centuries to compute may one day unfold in hours, perhaps minutes, guided by the silent bonds of entangled states. You picture this future not as a sudden arrival, but as a dawn slowly brightening. The first rays are already here. In 2019, a team at Google announced they had achieved what they call quantum supremacy, solving a problem their machine could answer in minutes, while most advanced classical computer would have taken thousands of years. Others questioned the claim, debated the scale, but the direction was clear. Something new had stepped into human hands. Yet this power is delicate. Entangled states are fragile, like soap bubbles shimmering in sunlight. A stray vibration, a breath of heat, a wandering magnetic field, and the bond collapses, the bubble bursts. This fragility is why quantum computers today live in large, humming refrigerators cooled to near absolute zero, shielded, protected, as if they were rare orchids growing in glass domes. Still, even orchids spread, given time, and the seeds of entanglement are already traveling. Imagine security, the kind you depend on every time you send a message, sign into an account, or make a payment. Classical encryption rests on the difficulty of solving certain mathematical puzzles. Yet with the arrival of quantum machines, some of those puzzles may no longer remain difficult. Codes could be broken, walls could crumble. But entanglement offers not only threat, but also protection. There exists a technique called quantum key distribution, where two parties share secret code by sending entangled photons. If anyone tries to eavesdrop, to peek at the message, the entanglement shatters, and the intrusion reveals itself instantly. It is as if you and a friend were holding a delicate thread made of light, stretched across the world. If someone else tried to cut it, you would feel the tremor at once. In such a way, entanglement becomes not only a puzzle of physics, but a guardian of privacy. Already, banks and governments test these systems. A secure quantum link between Beijing and Shanghai stretches across thousands of kilometers. Satellites beam entangled photons between continents. These are not dreams, but present realities, though still young, still fragile. You bring your awareness back to your hand, back to the device resting there. You might not see it, but within its circuits lie whispers of the quantum world. Transistors that rely on tunneling, lasers that produce photons, sensors that detect light with astonishing precision. The line between the cosmic and the personal is already blurred. The mysteries once confined to chalkboards and particle accelerators now hum softly in your pocket. And this is the quiet truth. Entanglement is not only an idea drifting among stars. It is in your networks, in your codes, in the experiments that will shape tomorrow's world. It is in your hands, whether you realize it or not. Yet, with each step forward, new questions emerge. If particles can remain connected across space, what does that say about distance itself? If we can harness these invisible threads for computation and communication, what might that reveal about the fabric of reality? The bond that began as an echo between two particles now stretches into your life, guiding technologies, protecting secrets, offering glimpses of futures not yet imagined. But behind each application lies a deeper question. Why does the universe allow such connection at all? As you breathe slowly, Resting in this thought, you realize that every discovery in your hands is also a doorway leading back into mystery, into questions that have not yet been answered. And softly, without hurry, you feel yourself drifting toward the next wonder. If entanglement can be used, if it can be woven into our tools and networks, then perhaps it can also reveal something deeper about the hidden structure of reality itself, about the quiet stage upon which all particles dance. You lie still, the quiet of evening wrapped around you. Your breath rises and falls like a tide. Somewhere in a hush, a thought begins to take shape. If particles can be linked across distance, what does that say about you? About the thoughts moving in your mind, the feelings stretching between you and another? Entanglement is usually spoken of in the language of physics, measured in numbers, tested in delicate laboratories. But you feel something in it that goes beyond equations. You sense a hint of kinship, a reflection of how life itself seems interwoven. Consider how your body works. Billions of neurons spark and whisper, passing signals across synapses thinner than hair. No single neuron knows the full story of who you are, yet together they create thought, memory, identity. Your consciousness is not in one place. It is a music of many notes, vibrating together. In this way, your mind already carries a kind of entanglement. Each moment of awareness is not the product of one piece, but of connection. A memory is not held in a single cell, but in networks, patterns, bonds. You are, at your core, a being made of relationships. And just as particles across distance reveal a hidden unity, so too do people. Think of the last time you felt someone's presence even before they spoke. The way a friend's silence can still say everything. The way your heart beats faster at another's joy or slows in their sorrow. These are not quantum experiments, yet they feel like echoes of the same principle. That connection is deeper than we can see. You imagine threads of light stretching between every person you have ever loved. Threads that hum when you remember them. Threads that tug when they think of you. You cannot measure these threads with instruments, but you feel them all the same. Perhaps they are woven of memory, perhaps of biology, perhaps of something science has not yet found a name for. Still, the image lingers. You are part of fabric larger than yourself. Science, careful and precise, rarely steps into such territory. But even scientists, when speaking of entanglement, sometimes lean toward poetry. They describe particles as knowing about one another, as sharing information instantly. These are metaphors, yet they reveal how even the most rigorous minds sense mystery here. And what of consciousness? Some thinkers wonder if entanglement could play a role in the way your mind arises from matter. Could the strange bonds of quantum states ripple up into thought, into awareness? The question is far from answered. Some dismiss it, some explore it, but the wonder remains. Could your consciousness itself be entangled with the universe? You feel a kind of spaciousness as you hold this thought. If your mind is not a sealed box, but part of greater weave, then every breath, every thought is connected to a larger whole. Just as a wave belongs to the sea, so too might your awareness belong to something vast. Even if entanglement is not the secret mechanism of thought, it serves as a mirror. It shows you that separateness may be an illusion. That distance, whether between particles or between people, may not be as final as it seems. Close your eyes and remember a moment of stillness with another person. No word spoken, only shared silence. In that silence, you felt togetherness, not through speech, not through touch, but through something subtler. Was it not like a kind of entanglement, where your states align without any signal traveling between you? This is the poetry of interconnection. It is not proof, not measurement, but a way of seeing. Entanglement reminds you that the universe is not a collection of isolated parts. It is a web, a dance of fabric. You are not outside of it. You are within it, woven through. Think of forests. Beneath the soil, trees send signals to one another through networks of fungi, sharing nutrients, warning of danger. The forest is alive not just as individual trees, but as a community, an entangled whole. Your own life is not so different. You live through bonds, through family, through friendship, through the invisible exchange of ideas and care. Think of the stars. Every atom in your body was born in the furnace of ancient suns. You are entangled with their fire, though they burned billions of years ago. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it forged in distant hearts of light, now carried within you. The universe is not just around you, it is inside you. And so entanglement whispers of a truth that is both scientific and personal. Connection is a foundation of existence. Particles remind you, trees remind you, your own thoughts remind you. As you rest, you begin to wonder, if the universe allows such bonds, if it builds itself not from isolation but from unity, then what else might be possible? Could consciousness itself be a vast, shared field, like a sky in which all minds are clouds? Could the sense of I be just a ripple in something wider, deeper, unseen? The thought is gentle, not urgent. It does not demand an answer. It simply rests with you, like a hand placed softly on your shoulder. You breathe, and the room around you feels both intimate and infinite. You are small, and yet you are part of something immeasurably large. The invisible threads stretch from the tiniest particle to the widest galaxy, and you are among them, entangled in ways you may never fully name. And in this quiet awareness, you begin to feel a question rising. If consciousness is a fabric, if entanglement is a hint of its weave, then where does this fabric truly begin and where does it end? You lie back in the hush of the night, letting your breath settle into the slow rhythm of waves. The stars above feel ancient, and yet their light reaches you now fresh, immediate. As you gaze into the dark, a thought emerges like a tide rising quietly to the shore. Entanglement may not belong only to space. It may stretch across time as well. You're used to thinking of time as a line, a neat arrow pointing from past to future. But in the strange landscapes of quantum physics, time is not always so simple. Sometimes it bends and folds, blurs and overlaps like threads in a woven cloth. And entanglement, that whispering bond between particles, does not ask permission from the ordinary rules you hold on to. It seems to flow through distance as if it were no barrier at all. And perhaps, just perhaps, it flows through time in the same way. Imagine a particle born today, its twin born yesterday. Though they never touched in the same moment, they may still be entangled, connected across the seam of time. What happens to one could echo in the other, not only across miles, but across hours, days, even years. This idea is not just a dream. Experiments hint at it. In laboratories, photons, tiny quantum of light, have been entangled in such a way that their bond stretches not only across space, but across different points in time. Scientists call it entanglement swapping, as if one particle could hand an invisible thread to another in the future, tying knots that cross the arrow of time itself. When you hear this, something in you softens, because, in a way, you already live with time entanglement in your own life. Your present self is tied to your past self. Choices you made years ago ripple into this moment, shaping your path, your breath, your thoughts. You are entangled with memories, some tender, some heavy, but all still alive within you. They tug gently at the fabric of who you are, and you are entangled with your future. 2. The choices you make tonight will ripple outward, touching days not yet born. In this way, you are always part of a dance between past and future, carried by threads you cannot cut. Think of memory. When you remember a childhood moment, the warmth of sunlight on your face, the laughter of someone you loved, you do not only recall it, you feel it. It rises into your present, alive again, though the moment itself is gone. Memory is entanglement with your own past, a quantum thread that time does not erase. And think of destiny, or the sense that certain futures are waiting for you. Perhaps these feelings are not certainties, but whispers in the threads you have not yet walked. Just as entangled particles anticipate each other's state, so too might your present contain seeds of futures already woven into the fabric. Science, careful and precise, explores this with equations. The mathematics of quantum mechanics allows for correlations that stretch across time as naturally as across space. But outside the numbers, the image feels almost mythic. It is as if time is not a river flowing in one direction, but a great sea in which all moments float, some close, some far, yet all connected by unseen currents. You imagine yourself standing on the shore of the sea. Each wave that laps at your feet is a moment in your life, present and vivid. Behind you,